Mr. Harris here, and welcome to a new video of Chapter 10. In this video, we're going to talk about what hearing is all about. So, of course, hearing is very important to us. Hearing allows us to communicate with one another, especially when we're having discussions. Hearing also allows us to avoid any danger that is incoming, especially when we're on the roads. So, how exactly is sound being produced? Okay, this is what we're going to talk about today: the production of sound. More specifically, how do our ears detect sound? So let's have a look. So first off, I want you to do a simple experiment at home. Just grab a rubber band, okay, and maybe ask someone from your family, your siblings, your mother or father, anyone. So one person would need to grab hold of a rubber band like this, okay, stretch it out, and ask another person to pluck the rubber band on this side over here. After doing this, first off, I want you to answer this question, even though you can already see the answer. But does the rubber band produce sound? The answer is yes, it should. And second of all, the person that is holding a rubber band, how what does the hands feel like? What happens to the hands? The rubber band is actually vibrating, so your hands will feel like they're vibrating as well. So I want you to focus on this word vibrating. I'll come back to that later on. Sound is actually produced, guys, by the vibration of objects. What do I actually mean? So first off, please write this down. Make sure your spelling is correct. Sound is produced by the vibration of objects. So more specifically, how is sound transmitted from the vibrating objects to our ears? So maybe when you were younger, you might have played with this paper cups, and then you have a thread or a string, and one person is speaking and another person can listen. So, for example, when you have a gong, or I could say a drum over here, when a drum is struck, of course, there are vibrations being formed. Also, you can hear them with an ear. Don't freak out, this is an ear. This is not something weird. This is an ear. Okay? So, what actually happens is the vibrations that are formed when the drum is struck, the vibrations are transmitted through the air to our ears. So, more specifically, actually, there are vibrations of air particles. So, vibrations, this keyword, I should say it all the time when we're dealing with sound. So, when a drum is struck, there are vibrations of air particles, and eventually your ears are able to detect this sound. Okay, so our ears, they detect the vibrations of the air particles, and that is how sound is produced. So, again, the keyword, I'll emphasize it again, vibrations. All right, let's move on. Can sound be transmitted in solids, liquids, and a vacuum? So what is a vacuum? A vacuum is when air is completely removed, or most of the air is removed. But for an easier explanation, let's say all the air is completely removed. Okay, let's first see whether sound is transmitted in solids. So let's see whether that could happen. Say, for example, you have a partner with you, someone at home. You can even do this experiment at home. Just grab a pair of paper cups and a string or a thread. One person will speak, the other person will listen. Does this work? Of course, this works. We can hear the other person speaking, so yes. And what is the reason behind this? The reason behind is, again, the word over here is vibrations. The sound vibrations are transmitted through the thread to the other cup. And in this case, if you look at the thread over here, the thread over here is the solid over here. So sound can travel through a solid to the other ear, for example. So in this case, thread is a solid, so the sound vibrations are transmitted through the thread to the other cup. So all good. Happen in liquids. So can sound be transmitted in liquids. Let's have a look. For example, we have a stethoscope. So this is what doctors wear. Okay, and then we'll put the chest piece inside of water over here, and you have a buzzer. So let's listen through the earpiece whether the buzzer will ring. So let's see, can you hear the sound produced by the buzzer? And of course, this is a yes. And what is the reason behind this? And it is due to sound being transmitted through the water to the stethoscope and then finally to the ears. So in this case, what is the liquid? The liquid over here is, of course, water. So you can even try this when you're swimming, for example. If you try to produce some sound, you can obviously hear it from the other person as well. Okay, and finally, let's see for a vacuum. So as I mentioned earlier, vacuum is a state where air is completely removed. Say for example, we have this apparatus over here. So you have a bell jar, you have a hammer over here with an electric bell, and you have a vacuum pump. So this is to remove air. Okay, first up, let's switch on the electric bell. Can you hear the bell ringing? Yes, because initially we haven't started vacuuming, the pump isn't turned on. So normally, of course, we will hear a sound. Now, what happens when we turn on the vacuum pump to remove all the air from the bell jar? So what happens? First off, the sound will fade while the air is being pumped out. Eventually, no sound will be heard when all the air is removed. So what does this tell us, guys? This tells us that eventually, when all the air is removed in the vacuum, no sound will be produced. However, will the hammer still be hitting the bell? Of course, it will continue to be hitting the bell because we haven't turned off the power supply, right? We only removed air. However, we will not be able to hear any sound, and the reason behind is sound cannot travel through a vacuum. So, from these three experiments, what do we know? Or what do we understand? From here, we understand that sound, it requires a medium to travel. What do I mean by medium? For example, it requires a solid, just like how we said it needs a thread. It would require a liquid. For example, sound could travel through water, or even gases. For example, the air particles in the very first example that I started off this video with. Okay, so sound travels at different speeds in different media. This is the plural form of medium. It is not the media you're talking about or you're thinking about. This is a plural form of medium. So sound travels fastest in solids and the slowest in gases. And as just mentioned earlier, sound cannot travel through a vacuum. And the reason behind is we have removed all the air particles, so there are no particles to transmit the vibrations. Hence why no sound could be heard. Alright, so let's wrap up. Sound needs a medium to travel. The medium could be gases, liquids, or solids. So let's answer these checkpoint questions very quickly. Sound is produced by, of course, vibration of objects. Question 2, sound needs a medium to travel. The medium can be gases, liquids, or solids. And finally, sound cannot travel through a vacuum. Yes. Okay, make sure, guys, the spelling is correct. I see some of you spelling it like this, vaccum. This is wrong. It should be W's. No, I mean two U's, not W as in the letter W, but two U's. VACUUM. Okay? So that wraps up this video. I'll see you guys in the next video and we'll start to talk more about sound and our ear, of course. Alright, bye for now.